But we are talking about app compat today. Let me get logged in here. I'm not on the screen, I know that. And specifically, my hope is to address those who are still looking to break up with Windows XP. How many of you still have some Windows XP in your environment? How many of you have a lot of Windows XP in your environment? Those who don't, what are you trying to get rid of? Anyone? Apps? Yeah, apps in general. That's what we're going to talk about. So the session is App Compat for Nerds, and it's that nerd perspective that I really want to address. I give a session at the Microsoft Management Summit. There's a little bit of overlap because there's input that the nerds need to provide to the project to make the whole thing go well. But the overall goal is to really better get a handle on how you deal with applications and how you use solid nerd principles to make the right choice, even when it seems counterintuitive to your nerddom. When we think about what it means to be compatible, incidentally, I actually do have some slides for this one, so apologize to the purists who are kind of used to my going without a net whatsoever, but some of the slides in this case I think are important to really convey the complete message. What does it mean to be compatible? To be compatible, at some level, it means that your application has no bugs on the platform you want that stop you from getting your work done. Now, rather inconveniently, this jerkface, Mr. Alan Turing, proved that it was mathematically impossible to ever achieve that first bullet. It cannot be done. And he did that back in 1936. Incidentally, that's the first time that Alan Turing has been referred to as a jerkface in all of recorded history. It can't be done. So the focus gets on that stop you from getting your work done. So when we think about an app compat process flow, most people look for a tool, most people look for a process that has the technical team shouldering it all and just churning them out and saying, here we go, they're all done, they're ready to go. If that's the case, your new software releases should never require user acceptance testing because you can always do a perfect job. If that's the case, then you shouldn't have to have a software help desk because you'll already know that everything works. Chances are you probably have both. So we want to use really sound, sensible principles for determining what's going to be a business breaker or not. Right? We're going to use real thought around understanding how we're going to test, what our acceptance criteria was going to be. One of the things that I really love to do is to build up a hierarchy of my applications that defines how much am I going to care about each of them. First hierarchy, 4 levels. Level number 1, a managed application. Those applications where I'm going to look at them before I upgrade every time. And I'm going to understand the potential impact for those because they're that important. If you're on my managed list, it's going to get some love every time. Beneath that, supported. Those applications where I'm never going to look at them ahead of time, but if you call me, I'll help you. Office. Nearly every Office document you've got probably belongs in the supported category. You're not going to look at every Office document because you can't afford to. But if someone has a problem and they call you, you're going to help them out. Unsupported. It's okay to run it, but if you call me, I'm not going to help you with it. Right? So back in the world of Office docs, your resume, I'm not going to support it. I understand you probably will have one, but if you call me with a problem, I'm not going to help you get a job somewhere else. Or maybe I might, depending upon your recent performance. And finally, banned. Those applications where I'm going to actively try to use techniques like App Locker to keep them from running at all. Within managed, I like to break them up even further and think about the level of treatment I'm going to provide. Platinum, gold, silver, bronze. A platinum app. When I'm working on an app compat project, the platinum apps are the one where I'm reaching out to the team and making sure I know them, have a relationship, that I understand what the app does, and all of the details behind what's potential to fail so I can give good guidance. Gold, they're doing full regression testing. Silver, they're doing some testing. Bronze, they're looking at it. If it passes, they shovel it on through. They're not spending as much time. it's real important to apply those principles of sorting and categorization, right? This is not super nerdy. Sorting is kind of easy. But if they don't do that, you end up continuing to default into this first in, first out mentality that considers everything to be equal. And it's not. If I have one app that's driving the majority of my business and revenues, start on it first, so that if I run out of time, the ones that fall off are the least critical ones, so that I can invest more in them, right? We need to make sure that people are not just saying, here, technology, take care of it, here's a pile, go through all of them, here's a process, it's a factory process, it's a tool process, and everything gets the exact same treatment. That doesn't make sense. When I think about my apps I also want to consider all of the emotional baggage that gets associated through terminology and through words and through the process. It's so easy for us nerds to look at that and go, oh my gosh, VB6, that is an old pile of junk that belongs out in the junkyard. What are we doing with that thing? There's a conversation I had literally today over the course of the day where the customer was saying, I've got VB3 and 4 and 6, and what do I do about them? And of course, you have the purists going, you throw them all away and you get new ones. Typical enterprise customer has somewhere on the order of 2,500 applications when they are well managed. You can't afford to buy all new ones every time either. So you need to be much more realistic and understand that old doesn't mean bad. How much of the world is run on mainframes today? Applications that can be 50 or more years old. They're old. They still work. Software is not like milk. It doesn't go bad by the end of the month or at the end of 10 years. But a better analogy is to think of software as a work of architecture and design which is intended to have a particular lifespan. And a good way to tell what the intent was by how long the vendor's willing to support it. Microsoft, mainstream support. We design our software to ensure that for 5 years we can keep it up to date and have full mainstream support. And we design it so that for 10 years we can continue to secure it. And we over-engineer it a little bit so that we have some padding so that we're not sort of barely making it over the finish line. Right? But the idea is that's what we intend to do. And then you've got to ask yourself, is the software I'm supporting for 12 years actually designed to be supportable for 12 years? Option A. Or option B, am I supporting the first one that looked like it solved the problem that successfully compiled? Because that's often what I end up supporting for a long time. It's all engineering. Right? It's how long I designed for it to work. On the screen, we've got some buildings that were designed for the St. Louis World Fair, another work of engineering. It's not any different than software. They designed these buildings to last for the World's Fair. It's about a year long. So they didn't build the buildings out of concrete or out of marble, as the original Greek structures that they were emulating would have been done, the ones that lasted for 3,000 plus years. They built them out of plaster of Paris and hemp. I love this analogy because you very seldom get to use the word hemp in a technical presentation, yet I do. That's kind of funny. It's okay. It's the last session. Turns out I'm actually not funny, but it's okay. I know that, and my mom thinks I'm cool. They're designed to last for a year, and so they intentionally then had plans to go in and provide more regular service. That every few months they were having to go in and patch things. It's all the design and the architecture. It's not about the age. You can design apps to last a lot longer on any technology, and that's okay, keeping in mind that at some point, everything eventually becomes irrelevant. And that's what you're balancing. I think from a technology perspective, we need to be both pragmatic but realistic in terms of expectations. You know, we've got some platforms that have been around for a long time, and we may look down on them, but there's some things that have really had a lot of legs. Visual Basic 6 has outlived Buddy Holly. It's been around longer than the Betamax lived. It's been around longer than Windows XP, and boy, that feels like that's been around forever. I get longer support on Visual Basic 6 than I will for a Hyundai, because it turns out that the Visual Basic 6 runtime will be supported for the lifetime of Windows 8, which goes until 2022. Wow, that's a platform, isn't it? That doesn't mean I want to be investing in new Visual Basic 6 today. It just means that I need to understand where I'm coming from, understand the typical enterprise environment has on the order of 50% of their applications built on top of VB6, and understand that from a future-looking perspective, I probably don't want that. How can I motivate my company to grandfather in the stuff that I have that's providing a ton of business value without making it my go-to bet for the future? Because if I make it a bet that, hey, old stuff is always okay, I can sometimes get into trouble. So what is this chart showing me here? This chart is showing me active exploits against various technologies. So when people think of platforms that they want to keep around, it's not just VB6. In this case, we're talking about another platform people love to keep around. A platform that I've never met a customer they didn't have a standard for it is Java. When you talk about Java, how many of you talk about Java and always mean the latest version of Java? How many of you talk about Java 1.6 Update 12? These are the number of active exploits that were successfully executed against different platforms in the wild. Not hypothetical vulnerabilities, but exploits that were already executed against those vulnerabilities. And guess what that top line is? Java. Why are there so many vulnerabilities that are being actively exploited? Because the bad guys have learned that people love to lock in on an update level of Java and not move for years at a time. So, it's good to have durability. That's terrific. Understand where you can be durable, because even Oracle will tell you, do not ever run an old version of Java. Always, always, always run the latest. So we've got these behavioral things to change. So as you can see, it's a balancing act. There's no cut and dry answer. Old stuff adds business value. Old stuff can add business value for a long time, but it can also add business risk. How do I balance that? How do I evolve it? This, to me, is the next challenge. So this is likely to be the last public presentation that I give on the subject of App Compat, which is kind of odd as the App Compat guy. But this is the next frontier, which is not just App Compat, how do I get my stuff barely working? Because right now we're in a mode of everyone's trying to get over that finish line before April 8th of 2014. They just want to get there. I'll introduce to you the greatest Windows 8 app ever. This is how much time we have left. 305 days, 9 hours, 1 minute, and 23 seconds until the end of support. Everyone's just trying to get there. App Compat is all about how can I limp across that finish line. The next frontier is how do I then start modernizing my stuff? Because it is a hard transition. If you're coming off of Windows XP or you have already, it is not easy. It gets easier, right? We'll talk about that and how we have a risk-balanced approach. But then we start thinking about how do I start evolving my applications to take advantage of new technologies rather than assuming that everything will be harder, right? In the world of IE, how do I start leveraging the new modes that IE provides, right? We'll start getting into those conversations. That's what I think comes next. But for right now, we just need to transition from the perfectionist, first in, first out model to taking a probabilistic approach and thinking through the mathematics of what we're trying to do. And those mathematics can end up coming up with some rather startling outcomes. So let me get into scientific mode. And this is a tool I use a lot when I see people doing things that are absolutely insane, to show them why it's actually insane. The first time I used this was, to me, revolutionary, because I just couldn't believe that no one had done this. I had a customer who was using the ACT data collection packages, which, by the way, we deprecated from 6.0 because from a statistical standpoint, they actually left you worse off than when you started, right? So therefore, probably not a real good idea to bet really heavily on them. But they were using them, and they were going to collect data from 100,000 desktops. And they were going to collect that data for 30 days, and they're going to upload it 3 times a day, every 8 hours. and in the end have 9 million logs that were going to come in. And then we said, all right, 9 million logs, right? Have you done this math? Because log processing takes 17 seconds per log. So you're going to have to wait that many seconds before you can review your data, or that many minutes, or that many hours, or that many days, or that many years. And I'm guessing you haven't allocated 4.85 years in your project plan, because you haven't done that math. When you think about what's the process going to be to get me from Windows XP to Windows 7, all right, let's take another one. I want to get from IE8 to IE10. I'm having a lot of those conversations right now. 8 to 10, right? So step 1 is always inventory. Find all the websites that people use. Step 2 is rationalize, and step 3 is test and remediate, right? It's right in ACT and on all of our documentation. Let's do inventory and rationalization. Inventory. How many unique URLs does the average company go through if you monitor internal traffic and external proxy servers? You end up with on the order of 250 million unique URLs that I have to go through. Okay? Seems like a big number, but you can kind of see, like, oh, you navigate a bunch of pages, fine, fine, fine. There's no real automated way to get through that, so we'll stick some humans on there. Let's have them spend about 5 minutes apiece looking at one, or 0.08 hours. And we'll get some people, I don't know, let's pull some people from offshore for $50 an hour to go through and look at that. And OK, so boss, I need $1 billion to rationalize our list of URLs. Incidentally, I do sell services for Microsoft Services. And if you have $1 billion for rationalization, I would love to take your business. I'm going to have a really, really terrific year if that's the case. But you can't afford that. You can't look at paying $1 billion. You haven't even tested anything yet. We need to do this math. And we need to continue that mathematical rigor as we consider all of the other things that we're working into our process. One of the conversations I'm starting to have a lot right now is all around the concept of tools, because there's a lot of tools out there. Third-party tools that will analyze applications and predict whether they'll work or not. And the tools, how helpful they are and when you will use them depends upon how accurate they are. None of them are perfect because, again, back to Mr. Turing, none of them can be perfect. In order to calculate that, we need to use the mathematical theorems of Mr. Bayes to compute what that means in terms of your predictions on a given application. So the primary tools that we see helping out in doing static analysis of applications moving from Windows XP to Windows 8 hit an accuracy of about 85% today. That number has been going down. Historically, they were at 95%. The number has not been going down because they've gotten worse at writing software. The number has gone down because the problem has become harder. The longer you wait to make the move, the more software you probably bought just because you felt like a refresh or there was some new feature you wanted. Any software that you've bought that's been released since 2007 probably works, which means fewer things are broken. Fewer things being broken means it's harder to find the ones that are, statistically speaking. So it's 85% accuracy. Still pretty good. But that doesn't mean that if I have a red flag on an app, that it's 85% certain to be broken. I need to apply the Bayesian algorithm to say that my estimate is that 20% of my stuff is going to be broken today. That number's been going down. When we shipped Vista, it was 30%. It was hard times for us. We spent a long time doing app compat. I have a tool that's going to tell me with 85% accuracy that it's broken, 15% chance that it's actually wrong with that number. And I can predict my posterior probability and compute that there's a 59% chance that if it says it's broken, it actually is, or if it says it's working, it actually is. Probably not what you thought. If your assumption was, if it says red is definitely broken, you're going to be wrong 41% of the time, and vice versa for the greens. If, however, you take this into account and go, you know what? This is one of my platinum or gold or silver apps. I'm not going to take its word for it. I'm going to UAT it anyway, and I'll use this for analysis. Then you'll get much better success from the tools. Accuracy matters, and accuracy is going to vary by the problem. When I look at the accuracy I get from scanning of an application for a transition from IE8 to IE10, the accuracy we hit, and this is optimistic, is somewhere around 30%. Which means if I predict initially that about 5% of my applications are likely to be broken, run the Bayesian algorithm again, and it turns out that if I flag an application as being broken, there's actually about a 2% chance it actually is. Should I bother doing that? We don't run it proactively at all. People love the notion of, hey, you know what? This is going to be a hard problem. It's going to involve a lot of people. Let's avoid the people and process it through a tool, scan it all, and just act on what the scan says. If the scan's wrong 98% of the time, is that a good idea? Probably not. We love the idea, but the problem space is literally infinite. There's an infinite number of ways to write a bug and a finite number of ways to find them. When bugs cluster, as they did coming off of XP, when UAC was a really big contributor, and that was very predictable comparatively, easy to find, we hit a lot of them. When you start getting into subtle differences in layout and rendering, a lot harder to find stuff. And the harder it is to find, the more tests you have to write, and the tools are never going to get far enough. Statistics. It's nerdy. It's not a debugger, but it's still nerdy enough, and this kind of stuff is important, this mathematical reality to keep us grounded in appropriate expectations, allowing us to filter through the noise and focus on the things that matter with the right rigor. Focusing on the noise is important, because if we consider all threats to be equal, we do some things that end up hurting us. For example, we had noise coming in suggesting in Pearl Harbor days that the greatest potential threats to our Navy in Hawaii came from residents of Hawaii of Japanese descent. So what did we do in response to that, treating that threat as equal to all others? We took all of our ships and we put them together so that we could more easily guard them against that potential threat. What actually happened is a bunch of airplanes flew in and said, hey, look at that. They're all right there. That's fantastic. Actually lining it up for really easy exploitation of what turned out to be the actual threat. And the magnitude of the threats was not at all the same. It was not smart risk management. And as we realize that we are not managing risk appropriately, we need to apply the law of holes. When you realize that you are in a hole, it is time to stop digging. We're programmed to think that there's always a right answer. And since there is always a right answer, right, our tests, there's right and there's wrong. You get a red X or a green check. We're programmed from first grade. There is no ambiguity. We don't teach statistics well, and when we do, people don't like them, by and large. And we're bad at them, and we're bad at intuiting them. But we need to understand the complexity of our world and how it applies to the overall impact of our processes. This comes from some work by Cesar Hidalgo at MIT that talks about the network effect, and you absolutely see this network effect in technology. So the specific work he looks at tries to understand the complexity and therefore the success of organizations and of countries based upon the extent to which knowledge is distributed throughout the society or throughout the organization. The same is true of technology. Your technical team is never going to understand all of the ins and outs of your apps, nor should you try to. But instead, you should look to find a way to successfully navigate those networks and celebrate the dependency and the interaction and the network as being your strategic advantage, not try to master it all and have technology have full knowledge of everything. We are responding to this in our tools, right? We look at what we've done with the App Compat toolkit in version 6. We got rid of down-level testing because, statistically speaking, we did as well as chance. So you really had two choices that would give you approximately equal outcomes. Option 1, invest in bringing a technology team in to set up a data collector, send out agents, collect the data, process it, and build you a report. Option 2, hire a high school kid, give him a quarter, and tell him to start flipping. Your outcomes will be roughly equal, statistically speaking. Since that's not what people actually expected, we just killed it. And now we just let you go through and monitor things up level, and we focus on empowering the user, empowering the pilot scenario, and really understanding how to gather data from humans who will be accurate so that it's actionable, right? When you think about the data that you can collect, there's tons of it. If you can think of an action that you will take differently because of that data, collect the data. If you can't think of how you'll behave differently with the presence of data, don't collect the data. Seems obvious, but it happens a lot. There's a lot of data that exists out there. As you think through your plans, we need to make sure we understand that we are bounded by, and this is a section from Plato, the law of non-contradiction. So for those of you who speak ancient Greek, which I'm guessing is half of you or so, well, you guys are not easily amused today. Am I really that unfunny? Yeah. I'll pay you later, sir. I've never heard of him before. Thanks, Dad. Law of non-contradiction. We need to be aware that we can't have non-conflicting goals as well and make sure that we're enforcing that. We need to think through some of the challenges we put in place. We need to correct the IT admins who may go in with some outmoded theory that they want to have explicit control, right? One of my little pet peeves is those folks who take a Microsoft Excel listing of all of the group policies on the system, and then they start holding meetings where they go one by one through each of them to pick the best choice for all of those policies. How many of you know people who are like that? How many of you are people like that? Right? Here's the possible risk of that. Just taking IE alone, this is the number of possible permutations of those group policies. The actual number. I did the math, right? So you can flip it to this many different settings. By way of comparison, this is the number of molecules in the observable universe. We do not have this many test cases for Windows or IE. So we don't know how the system behaves if you go through and custom pick something really completely unique and go one by one. You're in a configuration that no one else in the history of the universe has ever seen before. And therefore, you take on all the risk of how that's going to behave. With that, that's the end of the slides. I promise not many, but I think these concepts are important, that the nerds have to come in with the statistical sensibility to be able to say, if you're relying on perfection from your tools, you're going to be sad. If you are going to have a plan that requires you to touch everything, you're going to be sad. If you don't stack rank and understand the impact of your decisions, you will eventually be sad. The goal that I have and that I'm trying to espouse is one that says, always up to date becomes business as usual behavior. We're coming from a world where people like to lock in. Here's my stack top to bottom, and it's not going to change. I'm going to hold on, and maybe I can hold on for a whole decade, and then I'm going to uplift the whole thing and bring it over here and plant the same roots again. Isn't working as well as it used to. We've had a couple of inversions. We started off, the platform is changing all the time. We had things like, hey, now we have nested paths in DOS. And if I just have my app work on the new version of DOS, I get that feature for free. So I just keep up. I keep getting all these features. Oh, a TCP/IP stack. That's fantastic. I can use that too just by continuing to work. And then boom, right around 2000, it inverted. And the platform started to stay pretty stable. And you started to have some of the feature innovations being things like coalescing timers. How many of you even heard of that feature in Windows 7? right, probably didn't impact your app. It can, by the way, significantly affect your power management abilities, but you don't really base entire apps on top of it. The innovation came in the app, and we started to have the rise of the application megalith, the one where this is our retail app that has 9,000 things bolted and grafted and stapled and duct taped together to make this giant monstrosity that we're terrified to change anything underneath of. Well, now we flipped again. And now the platform is all of a sudden back on this cycle of, hey, HTML was kind of boring for a long time, and Ajax picked up, but that's 1997 technology. But HTML5, that's a game changer. And that's not done, and that's changing. I'm getting new features all the time. I'd like to hop on that for my web apps. Oh, Windows, now I have entire new app models and entire new security structures for following that app model that are potentially beneficial. New interaction models from touch and all of that that are completely different. And if I can just hop on, I can start to benefit from that innovation. But we're still living in that world of the application megalith. How do we move forward? So, with that preface, now we need to get practical. How are we going to go through and address our app issues? And when I think about that, I usually like to come up with a hierarchy of what I'm going to do in response to my application issues. And at the top of that hierarchy is nearly always fix or update the app. Ideal, right? And particularly as I think through what are the applications I'm dealing with, right? One of my favorite quotes ever, and it happens to come from a gentleman who's in the room, and I still tell this story all the time because it just made me laugh. We were working together, and we went to visit one of his subsidiaries, and they said, we've got this 16-bit application that's been driving our business for 18 years, right? Expecting the response to be, oh, well, we don't have to change it. But his response was beautiful. Well, then you got your money's worth. Make a new one. I love that quote. You got your money's worth. I was like, well, there you go. Not always possible. But the ideal is to have things natively working so we're not back into the old stuff. When we get past that, then we start looking at things like shims and policy changes. How many of you are aware of shims and have heard of them? How many of you feel that you've mastered shims? How many of you feel that you can kind of barely use them? Okay. For those of you who haven't heard of them at all, right, when we think about how we can address app compat issues in there, the app compat stack within Windows has two components. One of them is a component called the Program Compatibility Assistant, or PCA, which is basically encloses your apps inside of a job, and the job monitors certain behaviors of the application, and there are things we can detect and proactively fix using shims as the remediation approach. Shims are a way to change the behavior of the Windows API in such a way that it only applies to that application itself. Right? And PCA has gotten really good for Windows 8. Right? So in Windows Vista, it had a few rough edges. For Windows 8, until the first patch came out in February after we shipped it, we had one PCA scenario that was so overly triggered that you actually look at the stats in our Watson database scenario. The hottest scenario over the course of the first month of Windows 7 being in market had hit 1,200,000 times. The second most commonly hit scenario had hit 27,000 times. The first scenario was actually wrong about 98% of those times, so we had to fix that one. But after that, it was still OK. But in Windows 8, there's some really good stuff in PCA. We read your dialog boxes. And if your dialog box asks for Windows XP, we will automatically put in a version line to pretend to be Windows XP for you. I mean, this stuff is getting pretty sophisticated these days. Question is, how are we fixing that? So I'm going to go after shims in the nerdiest way I can possibly think of. And I'm going to, let's go into the Windows directory, and I'm going to decompose a shim itself. I want to go into app patch, and I'm going to pull this from think that's in AC General. And I'm going to do a couple of things. I'm going to start this off because it takes a while. And then while it's working, oh, it is, of course, not going to let me do anything. It's ridiculously inconvenient. So let me start up a second instance. Oh, really? You have non-multi-instancing code in here? Okay, there we go. All right. And let's decompose this one. Oh, that's a horrible one. You do have no multi-instance code in here. That's fantastic. All right. Well, that's really inconvenient. All right. I'm going to just pick a different one then. So a shim, the way it works is based upon how Windows itself works. From the perspective of an application, Windows at some level is really nothing more than a pile of DLLs, and thus is dependent upon how the DLL mechanism works. A DLL is just a chunk of code that you can reuse in anything else that you want to, right? That's, if you've done any Windows development at all, that makes sense. You see the DLLs, and we can just bring them in everywhere we want to. A DLL will say, I prefer to start here in memory. And therefore, you can say, OK, if you prefer to start at this address, then this function inside of you will be at this address plus this offset, and I know where you are. The thing is, not every DLL has the exact same preferred, says a very different preferred start address. Sometimes they're the same. And if they are the same, the first person to request that address is going to get it. The second person is going to have to be moved to somewhere else. So anyone linking to it can't just embed an address, because you can't guarantee it'll actually be there. So the way that a shim will work is it says, all right, well, Windows cannot just hard code the address, so we put in a table, a layer of indirection. And so the table for, let me actually zoom in on kernel 32, because this one we actually do shim all the time. If you're looking for a function inside of kernel 32, then go to the table for kernel 32 and look up the function. So let's say we want to pretend to be a different version of Windows. We want to modify the behavior of the getVersion table, getVersion function. We can just go into this table and say, all right, when we load it, we look at the start address of kernel 32. We add the thunk, which is the 98D4 address, and that's where the function is. And it's stored in the table. And then the code compiled into your program just says, whatever function this table points to, go run it. What does a shim do? It goes into this table and puts a different address of a different function that returns a different answer. So in the case of getVersion, whereas the real Windows would say, hey, hello, I'm Windows 8, I'm 7.2, sorry. The shim would say, hello, I'm Windows 5.1, I'm Windows XP. And that gets applications working. We just modify the behavior. Or in the case of some shims, like correct file paths, you just say, all right, call the create file function. We'll intercept it, and we'll look at it. And we'll say, oh, does it match this thing I want to change? If so, replace the string. If not, just let it pass through and call the rest of the real function by just modifying the entry in the table. That's all it does. And it only applies to this binary, because this table is stored in memory for every single process that you have. That's how we're able to modify it. It's called user mode API interception. It's how the shim engine works. Incidentally, that's also how appv works. Appv just replaces the address of the file functions and the registry functions and replaces them with appv's own copy that redirects them to the bubble. So far, so good? And to give you some sense of what we're able to do, a shim is not able to do anything that your application wouldn't do, because we're just putting ourselves in place. And from the perspective of Windows, it looks exactly like your application code. We can't tell the difference. So a shim can't do anything your app couldn't do. And you can infer two things from that. Number one, from a security perspective, if you have a shim applied to something, you're not loosening the security. What we do in our shims does not fundamentally change how Windows works. What it does is it rephrases the question to something that it can say yes to. Is that the one that I want? Yep. Here's an example. We have a shim called force admin access. And boy, that sure sounds like we're forcing something, doesn't it? All right, we're going to have a quick lesson in how to reverse engineer Win32 assembly language. Anyone here ever seen assembly language since college? So this is really, really easy, and it's not a prerequisite, but it's just kind of fun because it kind of helps us understand what exactly a shim is doing. So push just pushes stuff onto memory, and all we're doing is we're just saying, oh, we're going to push this text saying we entered this hook, that it's for this particular shim, and that's what we're doing. So, all right, it's just putting things in to go into, oh, DPF, that's actually just logging. All right, so the first few lines are just logging stuff, right? So that's not so interesting. Those are my log functions. Tell the shim infrastructure and the logging, if logging is enabled, that I use the shim. Otherwise, don't do anything. And the rest of it is what we actually do in terms of the shim. Here's what force admin access does. Force admin access intercepts the isUser and admin API as one of the many. And so in the case of isUser and admin, here's how it works. First of all, we take the EAX register. The registers are the fastest bit of memory on an x86 processor. Right? So this is where we do all of our work, all of our math. The first thing we do is we do an exclusive OR of the EAX register against itself. Exclusive OR means if I have 1 over here and 0 over here, then it's 1. But it's OR, right? They're different. If I had a 1 over here and a 1 over here, it would be a 0 because they're the same. If I had a 0 and a 0, it would be a 0 because they're the same. So it's only a 1 where the bits are different. An exclusive OR of something against itself will always be 0 because it's itself. They're by definition the same. In essence, this just happens to be the fastest way on an x86 processor to set something to 0. Next, we increment it. It also turns out to be a property of x86, and it's faster to set something to 1 by doing an XOR followed by an INC than it would be to just literally push 0 into that register. It's perf, right? This is Windows. We don't have time to screw around with things that are easy to read. We're about making things fast. So all we've done is said the accumulator register is now 1. That's the return value. Then we return. Ret. We're done with the function. Return 1. What does 1 mean in Windows? Anything non-zero means true. So here's all the shim did. The isUser and admin API that tells you whether or not the user is an admin just immediately and always says yes. Never checks to see whether you are or not. It just says yes. That's how shims work. We replace the entry in the database table to say, yep, here's the function to call. Then in the function, we either rephrase the question or just give you back the answer we think you want. And that's all we do. We don't change the security. We just change the behavior for that app. So you can see that. For those of you who are not familiar with shims, I publish on my blog a stock viewer app, and it has an actual guide that walks you through how to fix these things. You can see that that admin check failed right there. I can go into Compatibility Administrator and go in and create a fix at stock viewer, program files, x86, stock viewer, and I'm just going to target right at stockviewer.exe. Now, how many of you have found and or used stock viewer? Okay, a couple? Yeah. It's on my blog. Right? Just do a web search for stock viewer shim demo. I have it available in both English and Japanese. Right? So if you want some real fun, do the Japanese one. That way you won't be able to get any help from the error messages. And this has a problem with force admin access. Right? It's checking. We just want to pretend to be so that it works. So we just go in. Let me go home again. Force admin. And I can check that to apply this shim. Now, for those of you who are familiar with shims on Windows 7, how many of you are familiar with any differences for Windows 8? Because there's an important one. Stock Viewer is a .NET application, aka it's managed code. Managed code could be shimmed perfectly well on Windows 7. On Windows 8, the .NET framework is excluded from shims by default, unless you specifically say, I would like managed code to be in here. So if I have to go into the parameters, and here in the parameters from Compatibility Administrator, I have this module information which says, if I need to add something that's excluded by default, here's where I do it. On Windows 7, about the only time you'd need to do this is if you had a Visual Basic 6 application, because on Windows 7, the one directory we excluded was System32. And System32, right, nearly every Visual Basic 6 application was routed through msvbvm60.dll, the Visual Basic Virtual Machine, which rather inconveniently sits in System32, so we would include that. The .NET framework is now excluded in addition to System32. So if I include everything, I'm sure to get it. And I can be more specific if I want to get refined, but I'm trying not to spend the entire time reversing everything. And I'll call this TechEd. Drop this on my desktop. And now I've created a shim database to fix this. And this one is tuned to make sure that I'm also hitting managed code. That's an important difference. If you have a bunch of shims that got you to Windows 7 and you are going to Windows 8, you'll need to understand if your applications were managed code, because you may need to modify some of them. Just a heads up, right? We try not to break anything. That one slipped through. I've got some guys from the App Compat team trying to figure out who fixed that and where we took the approved regression on that, because that took some people by surprise that had actually happened. So I've created this shim database file. So we've gone from the internals. I've got a table in the binary. I'm modifying it at runtime. That's what the infrastructure does. I apply a fix that is just going to lie about being an admin, and I create this database table. I need to get this fix applied. How do I do that? From an elevated script processor or command line, I need to call a single line of script that will call the SDBinst application. SDBinst happens to be in System32, so it is nearly always in your path, so that you can call it with a single line of script. And I want to install that new database. That's how I would install that in an enterprise environment. One line of script, boom, it's installed. Now the application is fixed. For that problem, at least. Dialog box goes away. The final enterprise consideration around that is, all right, so if I fix it this way, do I install that database as part of my application installer? Option A. Or do I have one that I install across every machine in the organization that contains fixes for all of my applications? The latter is what we do for Windows. So for Windows, we shipped Windows 8, Windows 7, Windows 8.1 with a what we call sysmain.stb already on the box, and we update it via Windows Update. A lot of enterprise organizations choose to do a very similar thing. I'll ship with our image my organization shim database and update it via our software deployment solution. They find that more manageable. If the number of shims they intend to use are just 1 or 2, then they will often just throw it in the installer, just because that's easier than actually building up an infrastructure for managing it. Right? So far, so good? So that's how I fix stuff. Now the question is, what happens when that gets harder? So that was kind of an easy one, right? I took a default stock viewer, right? Real easy problem. It told me what the problem was. And then I got out the other side, and yeah, the fix aligned real directly to it. But demoware is really, really great like that. The real world is often not nearly as friendly. The real world is a lot messier. Here is one example of a failing application. This is a real application. This is from Quest Software. It's SQL Nav 5. And if I run it, just nothing happens. There is no error dialog. Nothing at all appears. Isn't that awesome? So now the question is, what's broken about it? So here's the creative part of App Compat, the troubleshooting. I know what shims are. I know they can fix some stuff. And yes, I can eventually learn them all. But I got to figure out what's broken about this thing before I can fix it. And I've got no clue, right? When I think about the whole debugging process, I think about it as a process that says, all right, divide and conquer and think things through. Always chase a hypothesis rather than flinging tools at things. Here I don't have a clue as to what's happening, so I'm going to have to start fishing for clues. So I'm going to take Dave Solomon's advice and, when in doubt, use procmon. And see if that tells me anything. And I'll reset this for my earlier demos. And go ahead and minimize this for now. Double-click it to launch. And I still saw nothing. Let me go ahead and stop monitoring it. Go into Tools and show me the process tree, what was run. And if I scroll, I'll eventually find that, here's SQL Nav 5, and it came to life and went away pretty quickly. So let's go to that event. And we'll scroll down to it. Here's SQL Nav 5. Here's where the process started. And I want to see just what happened for that process. So here's everything having to do with it. So we created the process. It was successful. So we know that even though we never saw anything, we actually did get it launched. So the bug is not in Explorer. The bug is actually in the program. And if we go all the way to the end, we can see the process exit. And rather conveniently, it was successful. So problem solved. That's what it's supposed to do, is nothing. Any questions? All right, thank you very much. Have a good day. All right, so clearly, it's not really emitting anything. And if I look in the event logs, I can see if I find anything there. All right, go into Windows, Application, and nope, that's just nothing on the applications, and everything else is too old, so it didn't drop anything to the event log. It's usually worth a check, right? We've kind of gotten programmed by event logs not being helpful to not look there, and the one time you don't, the answer will be hanging out right there, right? It always happens that way, so I always look just in case. So I still have no idea. There's no clue. There's no event log. It gave me a success code, so there's no error code there. So then I start going backwards and seeing, hey, is there anything that happened beforehand? It's like, oh, wait. Not too long before we started tearing ourselves down, we hit access denied trying to create this file. Aha. I think that might be the problem. So that's something I can fix. There's a shim called correct file paths, which will help me to fix that. So let me go ahead and create a new application fix targeted at SQL Nav by Quest. And I happen to drop this into a really weird folder just because I was in a hurry while making the installer for it. And I'm going to do correct file paths. And how I configure this is documented, is I'm going to put in the old path. And just so that you can see there's nothing up my sleeve, I'm going to copy and paste it from here. Semicolon new path, so user app data is where I want to put it. And I want to put it in debug.txt. So rather than having to go to a central location where I'm not allowed to write, I'll go to a per user location. Right? For those of you who are not in my Windows security session, which was the session right before this one, general rules of a standard user versus an admin. Standard users can hork all of their own stuff. They cannot hork other people's stuff. The C directory is shared by everybody. So if I can write there, I could potentially hork other people's stuff. Therefore, standard users can't write there. Or in this case, protected administrators. But I can write to my own stuff just fine, so if I redirect that, I should be good. So let's go ahead and save that and install it. It's a lot faster than going to the command line. It basically does the same thing. And try again. And what I'll do is I'm going to add to my filter, show me everything where the path contains toad debug.txt. So I can see the one was coming back as access denied. So let's try it again. Helps if I actually turn monitoring back on, doesn't it? You can see it's still not working. And look at what happened. It's still not working because I'm still hitting access denied. Huh. But sometimes I am redirecting it. And if I look at the call stack for it, I can see that I'm being routed through the shim engine. AC, the prefix, stands for app compat. So I'm in the AC general is actually hooking it up and changing the path. Okay? If I start going down to the other events, right, here is the access denied. The access denied was also routing through AC general. When correct file paths is not working, or any shim for that matter, there's usually one of two explanations. Number one, the shim is not wired up to it, often because it's in System 32. Now with Windows 8, could be because it's managed code. So we're actually not going through the shim engine at all for that particular call into the APIs, because it wasn't intercepted. In this case, we can see that we were going through it, and if we wanted to prove this to ourselves, we could also go through and add and include star and find that that also doesn't fix it. So option A, we're not included correctly. We have some evidence, and we could gather even more conclusive evidence, but trust me, this is actually the case. Option B is, hey, there's something that's not spelled correctly about it. Well, we copied and pasted it. So what could be wrong? So in this case, when we weren't intercepting it, it was in a call to create file A. Well, what I had done was I just hooked it up to a debugger. Oops, I want exes. File open executable, and opened it up. And let's get a better font size, because that's really small and hard to read. So let's do maybe a nice 20-point font. And wire that up, and I said, okay, well, we can put a breakpoint on that and see what's being actually output. I'm probably loading symbols right now. That's really awesome. This is taking a nice long time. There we go. And here we go. Breakpoint and kernel 32. This is a 300 level class, so of course we're using a debugger, right? 400 level class, we actually write assembly language. You should reflect that in your evaluations. And this is the specific API, create file A. And go. We hit the breakpoint. And now we're going to resolve some symbols. And there we go, create file A. And the arguments for create file A will include argument 1, argument 2, and I could reverse that. I want to dump the ASCII value that's pointed to but this second variable, because if I look at the definition of create file, I can look it up. Here's the create file function. It will tell me that this argument is the file name. And that aligns with this. And this is the actual text that's being passed in that's not being fixed. Create file, watch procmon for a while. Do you know how often create file is called? All the freaking time. So we don't spend any time rationalizing what's being passed in. We immediately, literal spring match. Is it this string? If not, then we go on. This does not match C:/that. They're different strings. There's no intelligence in this because it's called too often. It's too hot. So no match. So we would have to modify our shim right-click, edit fix, to correct how it was being passed in, which is just /toaddebug.txt. Save it, install it, and now we would be able to launch the app. So I wanted to give a couple of examples, right? Here's what shims are. Here's a simple example so you can see it. And here's an actual application that, wow, that was kind of a pain. I can't believe we sat there in debugger doing it. But no, we could solve it. And it turns out that another tool that you can throw at it is Lua Buglight. Lua Buglight shows you the actual parameter. And I actually used that approach. Right? Lua Buglight is a oh, wow, I don't have put it in my start menu yet. I've got it hanging out. I have it on my SkyDrive. I have all my stuff on my SkyDrive. And it is not on my desktop. That I can assure you. I have different apps that look like the Lua SkyDrive. I actually made the Lua Buglight logo. It's my one claim to fame. I didn't write the app, but my buddy Aaron wrote it, and I said, your logo is horrible. I'm making you another one. And I'll show you another problem that I solved, because someone else saw a very similar thing, and I said, oh, why don't you run it in Lua Buglight, and, oh, it doesn't do drag and drop. Open a report, and I'll put this at the desktop. I'll load this in. This is another application, a real customer application, and we could see they had a very similar problem. In the event details here, it actually shows you the actual param, and they had a slightly different problem, but it was similar. They did a / instead of a backslash, and a / and a backslash are not a literal string match. And I could do that without debugging also, as long as it's a permissions issue. Right? Real world's a little bit messy, but if you're patient, you can make your way through it. Was there a question in the back?
I did. You mentioned that Windows 7 comes with its own shim databases that gets updated by Windows Update.
Yep.
Does that have to be reinitiated again?
Nope. Automatically applied. So the stuff that Windows is fixing is already fixed. So you don't have to take an action. Okay. So if you look in the application list, which takes a minute to load, you'll see that there are literally hundreds and hundreds and thousands even. We can actually, it'll count the number for us when it's done loading up, of applications that are already fixed, so they'll never have been broken in the first place. Right? There are 7,239 applications fixed out of the box. A lot of them are games, but not everything. Right? Because a lot of these have been around since XP, and a lot of the XP fixes were coming off of Windows 98 onto the NT platform. There's a lot of stuff prefixed. These, no action required. You can extend it for the applications that you have that we haven't fixed yet.
So if there's an update to that SDB, you have to reinitialize it?
Nope. Just run Windows Update. It'll automatically install it the right way.
No, for your own.
For your own, it's already applied. They sit side by side. So when you look at what we're storing, when you register your custom app fixes, we'll go into, oops, Windows, type this, right, under app patch. Here's sysmain.sdb. We install that one. You also install yours. They don't modify ours. You can have multiple ones. And you can see here I have 3 of them installed. And I could install more.
So you make an update, it keeps the same name. It just knows to use that every time you...
Yeah, it's serial, right? So I go through and look at all of them. Right? So when I install my own custom shim database, it doesn't install them into sysmain. It has sysmain plus all of the ones that you have. And you can either make one big one or lots of little ones. The difference being performance. Right? The custom shim databases are invoked and searched every time you launch an exe. So if you think about if I have 2, really not that much of a difference. I'm opening 2 files and looking in one-line databases in each of them. When I start getting into the hundreds or thousands, there's a potential for a performance increase. What is the performance characteristics from a computer science perspective of opening up 1,000 one-line databases and searching in them? It's O of n, so O of 1,000. What is the potential impact of opening up a single database with 1,000 entries? Right, because the databases are jet-based. It's O of the log of n, or about 8. 8 compares, 1,000 compares. Eventually, it starts to matter. It takes a while, but there's a perf difference. You're not editing anything, you're adding new stuff. The other topic I want to cover in addition to Windows apps is we're kind of hitting a lot of challenges today in the world of web applications. And I know I kind of go back and forth on how much focus I put on each of them, but this is what's popping up as one of the bigger things based a large part on the fact that people are struggling to understand the compatibility we've built into the browser. So IE is not just one thing that we call IE. Right? IE is the shell that contains multiple different ways to render web pages. This has been true for a while. IE6 had 2. We called them standards and quirks. IE7 had 2. We updated standards and kept quirks the same. IE8 had 3. We had the new IE8 way of doing standards, the old IE7 way, as well as the IE5 quirks way. When we added IE9, we kept those 3 and added a 4th one. When we went to IE10, we added a new IE10 standards, and we also added a new interoperable quirks. People ask me all the time, can I get a virtual copy of an old IE on there, the whole shell and everything? And I said, we actually have IE8 still sitting inside of IE10. We figure you don't want to see a separate browser window. Why would you? You'd rather just have the site work. The challenge then becomes, how do I tell my site to work correctly? And I put that guidance on a blog post, XUA compatible durable, is how I always search for it. Using XUA compatible to create durable enterprise web apps, where I show, hey, here's all the different ways we could render a web page in each browser. And note that we haven't gotten rid of one since IE7. They're all still there. How do you tell the browser which one you want? You add either a meta tag or a header. Here's how they are applied, the order of precedence. And when people then inevitably come back and tell me, nope, that doesn't work, I tell them when it doesn't work, there's only ever been 2 reasons why. Number 1, you typed it wrong. And I'm real sympathetic to that because this syntax error I'm calling out as being a mistake, I copied and pasted from a finally updated Microsoft web page on how to do these things. So we gave you the typo, and you copied and pasted them. Shame on us. We fixed it. I'm sorry. The other thing that I see people doing is they put the meta tag too late. As soon as we have to run a script, we need a script engine. We need to know which one. If we're already running it, if you haven't told us yet, we're going to go ahead and pick the default. And at that point, it's too late. Right? Whereas if you wanted to pick a different one, you could do it like this. As long as it comes early enough, then it will work correctly. And then think about, how do I update them correctly over time? That's the guidance I give. But understand, you've got a bunch of stuff in there. And the understanding of that, we're still really fighting to spread that message. It's confused because we also have this crazy thing called browser mode. This is nothing but user agent string. This is what browser are we telling you you are. Document mode is the actual behavior that can differ. This is a quick and easy way to switch out behaviors. It's also set and forget, so I always close my window after I've done that. What we're seeing in terms of overall behavior of applications that are failing, well, one thing to be aware of is that we have a little bug in ASP.NET, so you'll want to patch it. If you see this error in the developer tools, that's an old ASP.NET. I've seen that a lot. My Comcast actually had that for a while. I was trying to pay my bill, it never let me, and I debugged it to this as well. So there is a patch required, but we're starting to see stuff like this. Have you guys seen anything like this? Hey, here's a recommendation. Use anything else. Hey, how about using a good browser? Right, now let's see how badly broken this is. This is refusing to run. Right? Oh, you're using a horrible browser. Let's go and pretend to be Chrome. We'll just give it a Chrome user agent string and see how badly broken it is. Well, one thing we notice is that this is not exactly the highest performing website in the world. But if it thinks it's Chrome and therefore gives it good HTML, turns out kind of works just fine. They're just kind of being jerks. And we're seeing that more and more, where we have all these like, hey, this doesn't work in IE, it does work in Chrome, and we look and we say, oh, when we give it an IE user agent string, it's giving me different HTML that also doesn't work in Chrome. It's just that they're treating us different because people still perceive IE as being IE6 or even IE8 as opposed to IE10, which can possibly behave like that, but doesn't always. And it's lack of mastery of all of the details of the rendering engines that can also lead to things like this. Hey, we're working on it. We're working hard. I've been using this demo for about 3 years, so I question their definition of the word soon. The problem turns out to be that they said, all right, here's this HTML5 application, and we're going to check to see whether this HTML5 element, a canvas element, was created. And if not, we'll just give you that error message and assume that it's because you're IE, because that's the only possible explanation for things going wrong. And then they added this one little unusual meta tag. I like to run this HTML5, but IE, can you please pretend to be your non-HTML older cousin? Please. So guess what happens? IE7 mode doesn't do HTML5. Incidentally, that's the default for your local intranet zone. Until you put in an XUA compatible asking for something higher, you will never go beyond IE7 compat mode if you leave the defaults, which means you don't get all of the goodness of modern IE. If we were to put this into the latest standards mode, it will refresh, it will default to that error message, and then it will start working perfectly well. They hobbled themselves. And enterprise web applications unaware of XUA compatible will also hobble themselves for no good reason. It's good to have the default to be the most compatible one, but you need to start labeling them and marking them and opting out to the good stuff, because there's a lot of benefits of using modern rendering engines. I did this on IE9. I haven't redone the whole suite on IE10 yet, but I will. If I look at the behavior I get, if I do SunSpider on what at the time were the most current browsers, and boy, you can see how much browser development has accelerated. This was back when Firefox 6 was out. They're at 21 now. This was about, what, a year and a half ago? Chrome 13, they're at 29 now or something like that. But at the time, this was the latest of every single one. And when we were in IE9 mode, we ran the fastest JavaScript of any browser there was. When we were in IE8 mode, we lost to Firefox, but we still beat Chrome. But look at what happens when we're running in Quarks mode or 7 standards. Incidentally, the two options you have by default for your internal applications, they're 10 times slower. Wow, so basically you're saying I can make my stuff 10 times faster by making sure they work in modern modes and opting them in. Certainly for my new stuff, I'd be crazy not to do that, but I need to be aware of that. So a lot of real goodness baked in to the overall platform. And when we look at what we are likely to have happen, right, it's not guaranteed. There still are lots of things I don't know about. We're trying to understand the real technical scope. We're always trying to get input from customers. My email alias is appcompatguy@microsoft.com. It's really easy to remember. I'll give you my card if you're going to forget that. Reach out to me if you think you've got a real problem. But my experience, since IE9, there have been bugs that require me to change code, which I could not fix using one of those alternate rendering engines, which I can configure using XUA compatible. Since we shipped IE9, has been 4 worldwide. And since IE10, it's been 1. And I'm about to show it to you. We actually had to fix this one for IE9. It broke again on IE10. Right? This is if you're in healthcare, you may have heard of this one before. We have 1 second to go. All right, I'm going over. You're welcome to leave if you want to, but I'll just real quickly show you what this guy was doing. That's going to beep at me constantly, isn't it? That's super irritating. Let's save the entire response, and I'll show you what this is. I'm not going to have time to fix it, but I can at least quickly show it to you. So on the desktops, checks.js, let's take a look at what exact logic this is doing. Right-click. Let's edit this with Notepad++. Let's look for the... Oh, actually zoomed right into it. That's perfect. What's it doing? Script engine major version is less than 5, or script engine minor version is less than 5. The script engine version for IE 10 is 10.0. Is 10 less than 5? No. OK, we're good. Is 0 less than 5? Yes. Grr. So we fail out. But then they fixed it for IE 9, which was 9.0. So I'm like, well, how could this break again? What was their fix? Because I actually typed on a TechEd screen the fix for IE 9. What did they do? Oh, here's their IE 9 fix. If script engine major version equals 9.0, so they also included some boxing to convert it to a float as part of their comparison. That's awesome. Minor version equals 9.0. Thank goodness that's an or both of them would fail. This actually is a no-op. The minor version will never be 9. Then they special cased IE 9 in the most crazy, least performant way they possibly could as their IE 9 fix put in place, as opposed to putting in the code I've now typed on what's been recorded and broadcast about 100 times. We don't yet have a lie for this. We are considering whether we need to. This is the one example I found that does it. Everything else that I've found so far, not a promise that it will be everything beyond that, has been literally addressable using the various browser modes that are packaged as part of the Compat infrastructure. And that is our goal, to find a way to just keep your stuff working while continuing to add new capabilities and balancing between compatibility and functionality. So with that, I know I'm over time. I thank you very much for your attention. I wish you the best of luck in breaking up with Windows XP.